the one, a runners club is analyzing access to parks in Austin, assuming that runners will go to the closest park and not run to parks more than a mile away. Determine the potential usage at each park based on the block population closer to that park than any other, but not more than a mile away. So the setup on this one is very, very similar to the last one. Instead of polygons representing these districts, the one difference here is that the polygons aren't all contiguously connected like the police districts. There's no gaps in the police districts. They all abut each other. In this case, we have polygons that represent parks, but they're little islands. They're little park islands. And so they, in some ways, function a little bit more like points. You're not going to have containment necessarily. You're going to have a nearest situation. There's still the parks in this case. Let's look at this one for an eye for which one is the target. Assuming that runners will go to the closest park and not run to a park more than a mile away, determine the potential number of usage at each park based on the block population closer to that park than any other, but not than a mile away. So we have to determine which one's going to be the target, where the data wants to go to. When you look at this and you see when it says each park, that's a good clue that the parks are going to be your target layer. You want to know for each park how many people come to it from only a mile away, though, not all the rest of the points around it. So our target is going to be the parks, and our join features are going to be the block population again. To have it, I'll just go to insert a new, I'll call this EX3, EX4 rather. And then we're going to add the population points again. So that was in the, I think, administrative. And then we also need the parks, which will probably be, I think there's a recreation one. No, there's just a parks one. And the parks themselves. Okay, so here's all those population points. Here's the parks. And she basically wants to know how many people within a mile do each of these parks serve. The parks are going to be our target and the population. And so it's very much like the last one. But instead of contain, we're going to want nearest. And we also, it's a one-to-many, the problematic one. Multiple points of the population are being squeezed down to one park. And so we need to run statistics on it. Just like last time, we want the sum of how many people are coming, but this time the only difference between this problem and the last one is that we're going to put a 1 mile search radius around it rather than let it be all the possible ones, with the rationale being that people might not run to a park that's over a mile away. Okay, so with that being said, we need to right-click on the parks layer to initiate this again, go to joins and relates, add a spatial join. Let's just see if there's any other parts of this problem we're missing. Determine the potential usage, and we have to kind of read between the lines here. What I think she's talking about here is the total number of people who live there, as being what she's referring to as by the total usage, would be usage referred to in the number of people. So parks is our target, block population is our join feature. This time we do, of all the choices here, there is within a distance of, so that would be a suitable one to choose here. If we did closest, it would just be the one single point closest. I misspoke on that one. We want within a distance. And then it gives us then what's the search radius. I guess I've done this before because it's all filling itself in automatically. We want a search radius of 1, and then switch this to statute miles. That's just going to be regular miles. But before we can move on, we definitely need to check our fields because, again, just like the last one, we don't care about how many housing units. We can get rid of that one. We don't want households. We don't want FIPS. We don't care about the block or the track, the county FIPS or the state FIPS. We just want population 20 to 10. And again, we want sum on that one. Okay. So that's the setup for this one. The target is the parks. The join is the block population within a distance of 1 mile. And the field that we're going to use is block pop 2010. That's the number of people in 2010. And the merge rule is to sum up all of those points within 1 mile. That should give us the right parameters for this. And then she just wants to know, again, if we look at the attribute table for the parks, we should be able to see a new column added onto this table at the end. That's population 2010, and indeed it's there. And we can assume then that the numbers that we see in this column, because we set this up, are the number of the sum of the population points that are within 1 mile of that park. Now keep in mind, there could be some people that are getting double counted. If there's 2 parks very close to each other within 1 mile of it, those same points might be getting covered twice, and that's fine. Those people would just have 2 parks as choices to go to. It nevertheless doesn't change the fact that that park within 1 mile of it has X number of people. So to answer her question, how does she wants us to maybe make a map out of this, is I think how she wants us to show it. Determine the potential usage, okay, but not more than 1 mile away. This question's written unclear, like what she wants us to do with it. But I think when you look at her right answer, it's a map that color codes the parks according to that new attribute field. So if we do that, instead of using single symbol for the parks, if I right-click on it, go to symbology, we're going to switch this to graduated colors, and again based on Pop 2010. And so we see some parks that have relatively few people that they serve, like these parks over here, because there's very few population points there, and then others that are in higher density areas coming out with much higher numbers. Again, I wish that she had written this question in such a way, like what's the median, what's the mean, so you know you have the right answer, you just run statistics on that. But she wants this map with the legend captured as the answer to it. If we run out of time, one thing I'm wanting to do is I'll send out to everybody before I leave the room the right answers for all of Chapter 10 exercises, so at least you can check your work as you're working your way through. It gives a few pointers if, again, if we don't get to all of these today in the next half an hour.
I mean, the problem that I had, it was that the answers are in the back of the textbook. There's no hints how to solve that.
Oh, right. Yeah. Okay, so that's another clue. Yeah, you can use the back of the textbook to see. She wants a map, but there's not the steps to get there. Yeah.
I mean, this one, it doesn't even say it wants a map. It just had a picture of the map.
A picture. Yeah, so in that sense, that's the only way you can know that that's what she's looking for. Yeah. Did she have the legend in there at least so you can see that, or is it just a picture of the map? Yeah. Not.
It wasn't even the whole map. It was just a map.
Yeah, okay. Yeah, that doesn't give you much to go on, truly. All right, so that was number 4. I'm going to do one more, and then we'll switch over. Did you guys remember if we have chapter number 5 on here to do?
We have
Number 5. Okay, number 5. Determine the number of wells situated in each census tract in Austin. Capture maps, plural, showing the wells per 1,000 people and the mean well depth. So she wants 2 maps, one that shows the wells per 1,000 people, and a second one that shows the mean well depth of each tract. All right, here we go. So, all right, which are these 2 layers? So we want a well layer and we want census tracts. So census, again, the 2 forms of census data that are provided for the Austin area, population points, and then census tract. Census tract is going to be polygons. Population points are going to, the block points, or the block population are in points. I'm going to start a new map for this. Call this one EX5. Add data. We're now going to find the, this will probably be administrative for the tracts. We find that there. And then we need to find the wells. So here's the census tracts. By the way, it goes block. There's a block level census. Block groups are bigger, like multiple blocks pulled together. The one more aggregated up from that level is tracts. This is like whole big neighborhoods rather than one block or block groups. This is like more like neighborhood level, and then it gets aggregated up to the scale of the county at one level up from tracts. This is already pretty big chunks of a town at a time when you see the tracts. Okay, so we need the wells. Anybody know? I'm guessing facilities. Nope. Environment, probably. And there's the wells. Travis Wells will be the ones I'm guessing. That's the only thing that says wells. So you can see it's probably like this will be one county's worth of wells. So there's going to be a bunch of these tracts that are included in the tracts layer, but are probably outside of the the so we'll have some with 0, obviously, because there may be wells there, but they're not going to join with this. Okay, so of the 2 layers, which one, the way this problem's phrased, which one do we want to have our target? Which one do we have as our join in this case? So let's look at the problem one more time with an eye for trying to figure out which one's our target. It says, determine the number of wells situated in each census tract. In this case, what do we want that target to be? That's going to be the tracts, exactly right. So we want to initiate this based on the census tracts, and the 2 fields of interest is the depths of the wells and then the number of wells, and then we have to normalize by 1,000, divide it by 1,000 to get the number of wells per 1,000 people. So we'll need to do that later. But to get that started, we at least just need a count we need 2 fields there. One that shows the total number of people per that tract, which that's already a field of the attribute table. So if we open up the attribute table for the tracts itself, the population will definitely be there. There's population 2010, so we can use that later to do our normalization, divide it by 1,000, and then. But what we want for this is new columns added on to the end of this. Square miles is the last column of any consequence for this one. There's going to be new columns added onto this for the number of wells and the depth, the average depth of wells is what we want added onto this table. All right, so we want the destination to be tracts. We're going to initiate this join based on right-clicking on the tracts, going to joins and relates, add a spatial join. Tracts is our target. The join field is going to be the wells. In this case, intersect, we want to choose contains, probably. It'll be kind of like that first one with the districts and the population points. And then it's going to be critically important that we go into the fields. Let's get rid of everything we don't need and then just think about the ones we do want. So of all the fields that have to do with the wells, we have a lot of them. Oh my gosh, this is a pain. We don't need casing materials. We don't need username. Oh my gosh, I'm so sorry. Material type, completion date, construction materials, reporting agency. I like to clean this up. We just want depth. We don't need water quality bin. We don't need level. We don't need water use, secondary water use, primary, hydropower, type of power, source of depth, and then well depth. Here's one that we do need, is well depth. And so when we click on well depth, what's important here is, again, it's just giving us the first, but we actually want this one, what she asked in the question is, what's the average? So we want to switch this from first to mean. And then I think the other one, all we need is counts. So we can get rid of every other field in here. And if we didn't get rid of all these, it would just be a matter of sorting through extra columns, which the block of the tracks already have tons of columns, so it just keeps adding on more and more. So I'm getting there. I don't want to accidentally click on the well one. That'd be such a pain right now. I'm just going to leave it at, I guess I could get rid of that one. Okay, so this is the important part, though, is that you choose the well depth and you put it to mean. Count's going to be an automatic. We don't have to tell it to a count. It's just going to be a join count is what we're looking for later. So once this performs the join, we go back into our tracks attribute table. And what we're hoping for when we scroll all the way to the right is there's a column for count, and there's a column for well depth. So indeed we get a well depth and then we're looking for a join count. So there's 36 in this track, 7 in this one, 37 in this one, well depth. And you notice that there are some zeros and some nulls. So remember, those are probably those tracks that are peripheral to the data, to this county data. And probably these tracks out here are the ones that are reporting null. There were no wells to run the math on for the mean value, so it just reports a null. All right, so we got the 2 that we need. We need to have how many wells per 1,000 people. So we need to take the population, divide it by 1,000. And then so we need a new column for this. So we'll have a new column that's the total number of wells divided by the population that's divided by 1,000. right? So we'll have to put parentheses around this. So to make this new column, again, going back to the chapter on attribute tables, let's just take care of the easy one to make is a map that shows the mean well depth per track. So let's just go ahead and make that one first, and then we'll tackle the second one next. So for this map, you'll just do a screen capture of this. Go to the symbology for the tracks, and then switch to graduated color, and then we want the mean, the well depth, which is going to be the mean well depth, and that's going to be, we'd have to look up the units on this, but probably it's in feet, and this is what that map is going to look like, is the average well depth per each. And you can watch in this video recording, they should range from 14 at the lowest to 2642 at the highest if this went right for you. If you happen to take the first or the sum for that join rule, it's going to come up with different numbers, but the right one to pick for this is the average. I'm a little surprised it rounded off to the nearest whole, but I realized why that happened is because maybe that column, let me just see here, attribute table for it, let's look at the depth. I bet it does have decimal places. This is C. Well depth, no, it's whole numbers, so that must have added that column as an integer one, so it's rounding to the nearest whole number for that average value. I don't know. Let me just check that real quick. Properties. Oh no, my battery's about to die. I need to go grab my charging cord. Yes. Little victories. All right. All right. What I'm going to do is the second half of this problem, and that is to take the population. She doesn't tell us if she wants us to use that POP 2014 or the POP 2010. Since we've been using 2010, I'm just going to, for my demo, use POP 2010 for this. Remember, what we want is a new column added onto the attribute table. That's the number of wells divided by the population divided by per 1,000 people. So we have to divide by 1,000 again. So for this, I want to go to my add a new field onto the attribute table. So I click on the add button here, and this is going to be number of wells per 1,000 people. So number of wells per 1,000 people. We definitely want this one to have decimal places. So for the format, the data type, we want to switch this from long to float. That's going to be an important step for this one. And then we'll hit the save button to lock in that new field. And then we can close out the field editor. And now when we look at our table and go all the way to the right, we should see this new column, number of wells per 1,000 people. Presently, all null values until we actually calculate the field to populate those numbers. So we right-click on the header, go to the Calculate Fields, and then we want to build an equation right down here that's going to give us that equation. So we want the number of wells, the count. There's the join count is the field that's going to tell us the number of wells, and that's going to bring that one down, and then say divided by. And then we need parentheses around this one. We're going to use the population 2010. We want it to order of operations, take the population divided by 1,000 as the denominator, the numerator to be the number of wells. So I'm going to have a parenthesis. I want the population 2010. This, I'm trying to do it all in one step. We could do it in 2 steps, but I'm going to do it in 1. So there we have the population 2010, and then we need to have a divide by 1,000. and then end parenthesis around this. That equation looks a little clunky in here, but basically the way to read this is we want the joint count, that's the number of wells, divided by, and in parentheses, population 2010 divided by 1,000. So should give us the numbers we're looking for. If it's correct, we can check against her answer, and so we'll click apply on this. It should fill in these numbers here. Certain rows, okay, so any rows that had a null value in it, it's just warning you it can't compute the values, but it looks like it did okay with all the rest of them. So some of them were zeros, some are 3 wells per 1,000 people, some are a fraction, like there's not even enough for 1 well per 1,000 people. There's relatively few. And we saw from her textbook answer that on the low end for that one, it's 0.08 for, but that's at lower than 0.08. So it's but on the upper end, just 12 per each track. So let's just sort this descending to see if we're getting upper value. So she's using, I got 16. I still consider that to be in range of what she's talking about there. I don't know why, but maybe she was using population 2014, but it's within the right range. I'm feeling like we got the right answer for this. So again, total number of wells divided by population divided by 1,000 in the denominator came out to work. To make a map out of this then, go to your tracks, go to graduated color. This time we're going to switch the field from population 2014 to the number of wells per 1,000 people. Here it looks just like ours. The upper end of the lower range is 0.55, so 0.6 is close there. The upper end of the range is 16 in our case. Again, probably just a number of, that's just a difference in the 2014. And so that's how that comes out looking that way. And let's just see how her answer looks in terms of the book. If we were to color it in shades of orange, we end up with these. It really looks quite similar in terms of the pattern of these different colors here. So I think we got the right answer for that one. Another screen grab of the legend and this to answer the question. 2 maps that come out of this one. Question number 5. Okay, so I'm going to hit pause on this again.